Well, listen, my name's Brian Vornge. I'm the Assistant Director of the FBI Cyber Division, and I'll give some opening remarks here this morning, and then we'll get into a very deep, moderated panel discussion with our panelists. So let's get going here. So welcome to RSA in 2023. It's great to be here for all of us. Again, many of us have spoken here in the past, myself included. And today our panel title is Hardening AI and ML Systems, the Next Frontier of Cybersecurity. Today we'll discuss adversarial machine learning and AI assurance frameworks, consider the threat landscape, evaluate real-world examples, and discuss how organizations can secure and build resilience in their AI systems. The landscape of AI and ML is rapidly changing. Advances in AI capabilities are accelerating beyond what most of us can reasonably predict or anticipate. The rise of large language models in everyday use in relatively short period demonstrates the disruptive nature of both AI and ML. It's no longer a luxury or a premium or a catchphrase for many organizations to have AI and ML capabilities. It is or will be necessary to compete in a fast evolving competitive environment. Many organizations will look to integrate AI and ML capabilities into their core business functions, but in doing so will increase their own attack surfaces. Attacks can occur at every stage of the AI and ML development and deployment cycle. Models, training data, and APIs could be targeted, resulting in disruption and data exposure. Organizations will face a dilemma of choosing between performance and security. The FBI is particularly interested in this space from a security and cybersecurity perspective. Securing networks and devices is essential to prevent and mitigate harm that can affect businesses, critical infrastructure, and our collective national security. This philosophy must now be applied to secure AI systems as well. Organizations too often neglect security when deploying these new capabilities. Threat actors, from unsophisticated cyber criminals to the most advanced nation-state actors, will inevitably enhance their tradecraft and devise techniques to attack AI models. However, sophistication is not required to exploit poorly designed ML models. Just a few months ago, one such criminal actor pleaded guilty to fraudulent schemes to steal California unemployment insurance benefits and other funds. This individual used a relatively simple technique to exploit facial biometric recognition systems that use ML techniques to authenticate identities. This is an example of a failure to integrate core AI assurance principles. More sophisticated attacks from more advanced threat actors are simply inevitable. Adversarial machine learning will impact operational technologies and information and communication technologies alike across the cyber domain. It is critical for organizations to design AI systems with security and resiliency in mind. Many organizations lack even simple awareness of this threat vector. Machine learning models and algorithms are non-standardized, meaning that unlike traditional cryptographic standards, for example, where the information is theoretically secure, unconditionally, there is no singular way to secure ML systems like we can do with data using encryption. There is no simple cure-all for protecting AI models. Scholarly articles on adversarial machine learning-based attacks have increased tenfold in just the past few years. In the last month, NIST released their initial report on AML, which underscores the emergence of this topic. The frontier is upon us here today. Today's panel will explore the importance of integrating the resilience and assurance into AI and ML capabilities. With me today to discuss these challenges and opportunities are three distinguished individuals who are leaders in this space. From my left, moving to your right. First is Dr. Christina Liagatti, Operations Manager from the MITRE Corporation, who has spoken on this topic at RSA previously and is one of the leading pioneers and security practitioners in the field of study of AML. To her left is Neil Sarabrani, CEO of Calypso AI, a prominent AI company that provides, among other services, ML model resilience through training and validation, and has numerous partnerships across industry and the US government. And finally, Bob Lawton. Bob and I were briefly former colleagues at the FBI Cyber Division before he joined the Office of the Director of National Intelligence and now helps lead their efforts on AI assurance as Chief of Mission Capabilities. Thank you all for being here today. Okay, let's jump in. First, Bob, then Christina and Neil. Can you start us off with discussing some of the core concepts of AI assurance and AML?
Yep, thanks, Brian. So got a good sound check. So I think when it comes to assurance from an OD&I perspective, we look at the entire AI stack from a technical security perspective, and that's one side of the coin for us. We talk about resilience and robustness. And then what's really important for us as well in development and deployment of AI systems for the intelligence community is being assured in our use of those technologies, which is why we use the term AI assurance, and that goes everything from policy, standards, and governance to privacy, civil liberties, and ethics considerations. So those are sort of the big picture things that we think about from an OD&I perspective.
Okay. Christina?
We're rapidly seeing this entire problem expand beyond just the security topic to incorporate equitability, interpretability. Bob brought up the robustness and resilience parts of the problem here. The privacy enhancing element of this, like this is all becoming a much larger problem even than what the traditional cybersecurity community is used to thinking about as just the security element of all of this. So it's going to continue evolving pretty rapidly, but it's pretty important to think about this as a holistic AI assurance problem and not just security.
And ultimately, it's really important to bring in the machine learning element into this. What we're really talking about here is the robustness of machine learning models. How do we make sure that models aren't brittle? Because when models are brittle, they are far, far easier to be able to penetrate. And ultimately, when you kind of think about the end-to-end of machine learning robustness or AI assurance, you're thinking about from a full lifecycle perspective, whether you're talking about foundation models that have been externally built or you're talking about internally built models. How do you make sure that everything from the data all the way to the model deployed in production has assurance built in using either various kind of human factors-based approaches or using software?
Okay, because we'll have the time, because part of my job is to moderate that time, I'm going to ask you each to go a little bit deeper. So Bob, back to you for a little bit more deeper discussion on concepts.
Okay, absolutely. So Neil just touched a little bit on the technical safeguards and the robustness. I will focus on sort of the imperative that we have from an OD&I perspective on doing assurance from a policy and governance perspective, and that's because when we're thinking about building and deploying AI systems for intelligence and national security applications, we have a really big challenge to make sure that the outputs of those systems are secure and within keeping of the standards and the practices of the intelligence community. Things like protecting privacy or personally identifiable information, making sure that we're not introducing bias into systems that would be not within keeping of the standards for the intelligence community. Things that when we go to our senior leadership across departments and agencies that they, as executives, are assured in deployment of those systems, and then to our oversight on the congressional side to make sure that we're being authorized to deploy these systems, that we're doing so in a safe and responsible manner.
Christina, how about a little bit deeper on equity and fairness and trade-offs?
Yeah, it's definitely something that I think the entire community is going to have to make some very informed risk decisions about, because much of the problem, as I said at the start, is in the broader AI assurance concept, right? And Neil, you brought up the point that so many of these systems, when you're incorporating them into a broader enterprise or system of systems context, you're only as strong as your weakest link there, right? You're only as safe or secure or equitable as your smallest system. So much of this problem is going to come down to teaching our leaders to make informed risk decisions about the equitability or robustness, resilience, security concerns of this entire AI assurance topic. The equitability and bias elements of this specifically are rapidly evolving because it's so difficult, I think, to, as a community, look at those as a quantitative instead of qualitative kind of problem to be working through and solving, right? Like working at it at the metrics level is actually quite challenging. We've grown out of a lot of the security space in solving the AI security problem, right? So we've got some very good tools and techniques to build off of the cyber community, but the equitability and bias issues that we're facing as a community, breaking that down into metrics that can be somewhat generalized and assessed across all the different systems that we're facing, at least thinking about the data concerns, right? So many of the equitability problems that we're facing as a community come from just the inherent data that we're using, what our models are being trained on. A lot of that is going to continue to be more of a problem for us, and I think we need to continue to break that down into as much of a technical detail metrics layer as we can to start to solve it.
And Neil, how about just a little bit deeper on AI assurance from a security perspective?
Yeah, so I think it's actually really interesting. I don't think that AI assurance at its kind of core is a traditional InfoSec problem. It's a machine learning problem that we're trying to figure out how to translate into the InfoSec community. So the metrics that matter are, for example, your standard data science metrics: recall, precision, accuracy, F1 scores. The underlying kind of most advanced threat actors are approaching this from an ML research perspective, which is why you see more advanced kind of work in the computer vision space than you do in the kind of tabular or in the cyberspace as a general rule of thumb. So I think it's kind of incumbent upon us to be able to figure out how do we actually take these underlying ML concepts, how do we take this machine learning research, and how do we translate it into both the parlance, the concepts, as well as the kind of standard operating procedures within a SOC context that make sense within InfoSec community.
Thanks. So from an FBI perspective, we also obviously have equities in this topic. We do incorporate AI and ML in limited situations with strict adherence to Executive Order 13960, which governs all of our work in the government, provides guidelines on appropriate implementation and use of AI. I think most importantly is we always have a human in the loop, and particularly since the FBI is a law enforcement and an intelligence agency, we undergo a rigorous and strict process before any technique using AI or ML is approved and deployed. Bob, can you give the OD&I perspective on safe and ethical use of AI in the government?
Yeah, absolutely. So I touched on it a little bit, but I'll sort of reinforce the point. When we are building these systems for intelligence and national security applications, that's a high-risk, no-fail mission. In terms of the technical security, we have to make sure that the systems are assured that system output and system performance are within keeping of sort of our risk tolerance, depending on the system. So we have to be exceptionally sure that we can trust the outputs of those systems. And then again, back to my point on assurance and making sure that we are not deviating from the norms and standards and the safeguarding privacy and civil liberties within the intelligence community. We take that challenge very, very seriously to make sure that we are within our authorities and within constitutional protections. And so making sure, as Christina alluded to, that we are building in safeguards and that the outputs of those systems are non-biased to the extent possible, and that we're not injecting any additional biasing into outputs of those systems that would sort of take away from the authorities that we're charged with.
Okay, great. So we're now going to switch gears a little bit and talk about AML and adversarial attacks. So Neil, then Christina, can you give us insight on the threat landscape now and in the near future? What type of attacks exist, and what are some real-world examples? Neil?
Yeah, of course. I really appreciate that. I think at a baseline level, you probably want to define an adversarial machine learning attack as when someone with the intent to disrupt a machine learning system is acting. And ultimately, what we're seeing from a threat landscape perspective is some stuff on the high kind of end side of the house, but a lot more threats from a low end perspective. Low end being a human kind of fiddling around with inputting many, many times into a machine learning system until they're able to get around the boundary conditions for the model and actually be able to successfully defraud or successfully attack a system. Ultimately, there are kind of at a very, very high level, two types of attacks that occur. One is an evasion attack, and two is a data poisoning or data-based attack. And then there are lots of attacks within there, some of them that are kind of cooler, but we see less often, like a sponge attack, for example, the equivalent of a DDoS attack for machine learning systems. But going back to it, a data poisoning attack is ultimately where you're taking the underlying training data and you are in some way compromising it, and an evasion attack, or in the LLM world on Twitter and in other places popularly called a jailbreak, is when you're trying to get past some of the constraints instilled by the model designer.
Can you go a little bit deeper, Neil, on what a sponge attack is?
Yeah, so sponge attack is really cool. We've seen a lot of work in the research literature, but we've seen kind of less outside of the research literature on sponge attacks. But it's essentially where you're taking the parameters of the model or the layers within the neural network, and you're essentially trying to cause the neural network to use more compute to the point of potentially exceeding the amount of compute available to the system and taking the system down.
Okay. And any comments on the term we all hear, meta learning? What does that mean to you?
So I think meta-learning kind of traces back to reinforcement learning as a general concept. And the most popular approach that's used within the large language model space right now is human reinforced feedback learning. So it's essentially where you are training your system to have certain hyperparameter-based goals. And you are retraining and retraining and retraining until the system ends up achieving the end state.
Okay. Christina, any comments on that, or welcome your thoughts on real-world examples, and then we can go back to Neil for real-world examples as well.
Yeah, absolutely. Building on Neil's points about these attacks having a wide range in the level of sophistication that we've seen. So many attacks that are very low levels of sophistication have been successful, and I feel like the malicious actors in this space have a lot of room even to evolve, but they don't actually need to yet to take advantage of these vulnerabilities of our systems, which is why we're seeing so many low level of sophistication attacks be successful. One that we frequently talk about was a $77 million loss by the Shanghai Tax Authority, where it was just a couple, like not even nation state actor level here, right? This is just a couple of individuals buying some cheap cell phones and headshots off the black market, creating a modified video feed of just a head slightly turning, eyes blinking, opening, closing its mouth, right? Something that any human would easily spot. But over the course of 2.5 years, they were able to successfully repeat this fraudulent scheme and get away with $77 million by taking advantage of the vulnerability of the facial recognition system incorporated into the broader Shanghai Tax Authority system, right? So it's quite simple to take advantage of some of these vulnerabilities. And to Neil's point that you made earlier, I don't think we're even having to see so many of the malicious actors in this space become particularly sophisticated in what they're doing to exploit these individual systems. They're more just poking at them and seeing what works to evade or erode the performance of the machine learning system that is built inside of that larger enterprise or system of systems context. So much of the community is taking advantage of GPT-based systems or excited about and deploying large language model or generative AI-based systems right now, and even just the prompt injection pathways that are starting to open up within these systems is just kind of mind-boggling, like how quickly and naively we're deploying these systems without realizing how vulnerable we're making our broader system of systems given that application. One of the Atlas case studies that was reported to us just recently here was a MathGPT attack that brought down their server for a couple of days, exposed their GPT API key. It was actually a German master's student that was acting as almost a red teamer, right? He wasn't even a malicious actor taking advantage of having access to that API key or using the server being down for a couple of days for malicious means. He was actively trying to report those vulnerabilities to the MathGPT folks while he was finding them. But I mean, they didn't realize when they were connecting GPT with a Python front end that they were massively exposing their system for all these different actors to take advantage of that vulnerability. So yes, we're seeing these real world attacks happen in the wild and evolve very rapidly as well as more actors are finding these vulnerabilities and realizing how they can take advantage of them.
Neil, any examples you want to share?
Yeah, we're also seeing traditional cyber risks only become exacerbated with kind of the development of some of these publicly available large language models. Spear phishing is a really, really good example of that, where the quality and the number of spear phishing attacks has just gone up wildly. And then within the kind of context of your traditional adversarial machine learning risks, I don't know if anyone saw the news article recently or news articles recently about the French tax authority using overhead images to be able to identify pools within France. There's been some really, because pools in France are taxed at a higher percentage. And there have been a number of examples that we've found kind of publicly disclosed and publicly available of folks trying to figure out how do they leverage some of these concepts to be able to hide their pool from being discovered and thus from being taxed at a higher percentage. And I think that really goes to show the kind of impact that some of these threats can have and also the need to take security measures. Machine learning systems are now being used within the context of financial transactions. And anytime you have systems used within financial transactions, it's kind of up to the InfoSec community to figure out what are the ways that we mitigate that.
Great. So Bob, we're going to switch gears a little bit. So what domains and industries should be concerned, and how does this parallel traditional cybersecurity? So we'll go to you, Bob, and then to Neil, and then to Christina for your thoughts.
Yeah, this is, I think this is probably one of the most important questions that we can have at this conference. It's every industry, every business sector, and every domain that's considering use of AI. I think we should think of AI certainly as an enabling service, and it's a very, very powerful tool. But I think that it should be considered an additional attack surface on top of normal IT or business infrastructure. So I think it's just very, very important that everyone who's thinking about internal development or adoption or procurement of AI systems does so with an additional layer of risk mitigation or risk management on top of that, and think about these truly I know you said it's outside of sort of normal InfoSec lanes, but it should be considered right in parallel with that.
So Neil, same question to you, but in addition to whatever is on your mind, any comments on low-end attacks and them being understated?
Yeah, of course, and completely agree with you, Bob. I think it's a kind of next generation or a new generation of InfoSec attack. And the reason why it's an InfoSec risk is because ultimately these are malicious actors that are trying to figure out a way to get around the system. I think that there is a new skill set that many folks have developed in terms of how to address or how to think about these types of risks. However, and you need to kind of think about different concepts in order to be able to address these risks. From a low-end perspective, we've also seen a lot of examples within the context of bot farming, where, especially within the context of video games, and World of Warcraft, Clash of Clans, and your other kind of very popular multi-player games, folks are trying to figure out ways in order to be able to get more credits within these games, because more credits can be sold for dollars. And they're often, really, really leveraging kind of the manual process of almost manual pen testing these machine learning models in order to be able to get more credits than the game allows.
So Christina, same question to you, but also real specific focus, if you don't mind, on the contrast of sophistication, low level versus more complex.
Yeah, as more of these attacks happen, I think we're going to see much more of the malicious actors having a higher level of sophistication in these attacks, but right now they don't have to, which I think is what's really interesting about this space. We brought up earlier that you're only as strong as your weakest link. And so much of these systems that we're deploying, and so much of the problem itself is bigger than just the AI or machine learning model that's being attacked, right? We're not just talking about adversarial machine learning, we're talking about AI security and assurance, the broader umbrella, because so many of these systems are being incorporated into our broader enterprise context. And the adversaries can take advantage of the combination of traditional cybersecurity attacks, right? That Shanghai Tax Authority attack was primarily enabled because they were able to buy personal identifiable information and those headshots off of the black market to create traditional privileged access accounts, right? So it's very much a hand-in-hand concept, and you can really see how this has so much more legroom to evolve in its level of sophistication. Brian, you actually brought up earlier an attack that was like a $900,000 loss for the state of California. That one was just a guy with some really bad wigs and some fake IDs, and it was entirely enabled because that low level of sophistication attack was on how the AI and machine learning system was being incorporated into that broader system of systems context. We've started to see some much more sophisticated attacks come up in the community, but it's going to continue to evolve, I think, fairly rapidly while we're in this proactive window. So many of the threat actors in this space, I think once they're having to combat good AI security practices, good AI assurance practices, it's going to get escalated fairly quickly once we see our own organizations putting in those practices and then the actors having to get a little bit more creative to take advantage of it.
Okay, so now we've talked about the problem. Let's talk about mitigation. So Neil, we'll go to you first, then Christina, then Bob. So how can we mitigate against the harmful effects of AML attacks or poorly designed ML models?
Yeah, that's a really good question. So obviously, just like within any kind of standard security model, you never have the ability to prevent these types of attacks entirely. It's all about threat and risk mitigation, and it's almost always about your kind of Swiss cheese strategy. What are the set of practices that you're putting in place end to end to actually mitigate some of these risks? I'll name a couple of mitigations that you can take, and then I'll let Christina and Bob and kind of continue the conversation. So some really simple ones, and a couple of these are actually going to be counterintuitive. So one is you can actually use simpler models. So when you have the ability to use, a linear regression model instead of actually using a neural network, you should do that, because the fewer parameters within the model, the smaller the model. As a general rule of thumb, the smaller the attack surface is. The smaller the attack surface, the easier it is to actually secure a model. Two, making sure that you have the data lineage side of the house and you understand the actual underlying data that you're using to train your machine learning model is key. Three is investing in tools, technologies, products that actually allow you to test your machine learning models in automated ways and to monitor your machine learning models as you actually deploy them and run them in production are a couple of the things you can do.
Christina?
So many of the mitigation techniques that our community is starting to come up with are rapidly evolving, I think, right alongside these threats as they come up. We actually just released a draft version of the mitigations layer of the MITRE ATLAS framework, which is directly built off of ATT&CK and meant to be used right alongside it, right? So much of the community is working together right now to further refine what mitigation techniques we can employ. But to Neil's point, so many of those are just good practices, right? Like it's not just, a really fancy adversarial layer or being able to patch a data set, right? Like it's not even necessarily that complicated. Much of the ways that you can mitigate these threats is even just thinking about the amount of information that you're putting out into the public domain on what models you're using, what data you're using, where it's coming from, what the broader system of systems context looks like around that system. Would you put out a bunch of press releases on your security practices? Probably not. So thinking about how you're even just appropriately using and talking about the systems, the AI and machine learning systems in your system of systems context can start to help a lot. But our broader community is working really hard right now, I think, to both be creative in sharing that ground truth on the data that we have about the real threats that our community is facing and the mitigation techniques that we can start to mature and build and share tools and capabilities around as well to secure our systems in a much more collaborative environment as well.
Christina, in my prep notes, I have a note about collaboration with NATO. Any thoughts?
Yeah, absolutely. So we actually just launched a NATO exploratory team about a month and a half ago, focused entirely on AI assurance and security to both share threat intelligence in our international community, as well as start to develop more of those tools, capabilities, priorities, largely built out around the Atlas framework, right? So this is all about leveraging tools and resources, capabilities that the community already has in place and making it more efficient, more shared, more open sourced where we can across the broader community. That's exactly what we're building off of for the NATO collaboration here, is both to share the ground truth and share the mitigation tools, capabilities, and strategies.
Okay. Thank you. And Bob, collaboration across the government, the Atlas community, how resilience builds into AI assurance and governance. Your thoughts?
Yeah, absolutely. And so, Christina, thank you for teeing up my my comments on partnership. And so I know it was just a little bit more than a year or 10 years ago, I'm sorry, when the NSA director, General Alexander, came and he briefed at DEF CON for the first time. And I think that was sort of the first foray of the intelligence community and sort of the national security enterprise of the US government really establishing and making clear that it needed to build partnerships with industry on the cyber side. I think that's where we're at right now on AI security is we need to be very intentional and move out on capacity building and partnership building. And so I think things like the Atlas framework that our colleagues at MITRE have developed and are continuing to develop, as well as things like the NIST AI risk management framework that was recently published. I think those sort of set it level sets for everyone on the things that we need to do to start buying down risk in this space, but I don't think that we can underscore the necessity of building partnerships within the government, sort of on the national security and then the federal civilian side, which is a work in progress because it takes a lot of capacity, but then also building in trust and starting to build communication lanes within the government out to our industry partners to start sharing AI incident information as well as being able to co-develop mitigation strategies.
Thank you. So, we in the FBI and the rest of the federal government are part of the solution, but organizations like Calypso AI and MITRE and the companies they provide services to are an even greater part of the solution. We need to collaborate to establish best practices and then practice them together. We need to share information, threat reporting, and awareness. From an FBI perspective, we always want to be a trusted partner with all of your organizations, but we want to foster that strong relationship in the easy days, the days before something goes wrong, when we can build trust-based relationships, when we can share bilateral threat information that we're seeing and that your organizations are seeing. Bottom line, to do as much on the preventative side and the mitigation side before there's a real need to solve a problem. Neil, and then to Bob and Christina, final thoughts before we start to move towards close.
Yeah, we have a really unique opportunity here as a community. We're aware of the fact that there is a threat. We're seeing early incidents of this threat, but the threat is not full-blown just yet, and just yet as the key operative word here. We have this unique opportunity to actually really, really focus on building mitigations, building and creating a culture of understanding for the next generation of adversarial machine learning risk, both for your internal models, your external, your third-party risk, and really on a full end-to-end life cycle perspective. Let's not miss the opportunity to actually mitigate against the next attack surface.
Neil, in my prep notes, and one thing we talked about before we arrived is this term hallucinations. Can you just touch on that briefly?
Yeah, so hallucinations has become kind of a popular term in the media in particular recently. Really, that just means wrong information from the model. And ultimately, there are a couple of issues related to that. So one is the time dimensionality problem. So for example, if you ask a machine learning model, who is the president of the United States, depending on the date it was trained, it might give you different answers. Those answers may be correct, but they might not be correct today. And two are issues from a generative perspective in terms of how the model is generating information. I think the broad space of hallucinations also falls under your kind of AI risk and your AI assurance umbrella. And from an organizational perspective, how you're creating the conditions for what do you trust from an output perspective within the context of a large language model, and what software or practices are you taking to mitigate false information that could potentially come from models. The other risk that we're starting to see is generative models creating false information, being retrained by other generative models, and on and on and on and on, and kind of this almost OODA loop of false information being generated.
Bob, thoughts on private-public partnerships and the benefit to industry and government?
Yeah, I think this challenge is going to be big enough that industry can't do it alone, government can't do it alone, and we can't do it without the research community as well. So inside ODNI, we look at intergovernment partnerships, private sector partnerships, and partnerships with our academic researchers as well. Really trying to build a robust network of developers and practitioners and security-minded entities within each organization to build out this capability, to your point, while we still have a chance. I sort of, when I'm talking about this problem with leaderships inside of ODNI and the intelligence community, sort of used the framing comment of, imagine it's 1985 and you hear about this internet thing and you're kind of sure you know what it is, but you're not really sure what it is or what it's going to do. That's kind of where we're at now with AI. It's here and we're kind of playing around with it. But imagine if it's 1985 and you knew the challenges that we were going to face in the cyber domain now. What would we, as a community, as an industry, do differently 35 years ago? And that's exactly where we're at with AI right now. We have the time and the space to get it right.
Great. So to echo Bob's sentiment, certainly at the FBI, we're eager to build relationships across industry with companies like Calypso, but also with those who receive the services. So let's just talk about what's next. What does success look like? So Neil, then Christina, for your last thoughts.
Success starts with understanding the risk, understanding, what the problem is, then defining what the posture of your organization is, and then figuring out, what the solution for you is. Some of that involves software like our products, but some of that also involves your internal processes, your internal teams, and your internal understanding and setup from a machine learning perspective, as well as frequently internal collaboration, because your data science teams within your organization are often the ones building machine learning models, or your individual business units. And so how do you collaborate with them from an InfoSec perspective to help keep the work that they're doing safe?
So much of this problem is going to be bigger than what just our security teams are solving, right? This is not just a cybersecurity problem. It's not just an ML developer problem. This has to be solved throughout the entire product lifecycle. Neil, you brought this up earlier, at every layer of development and deployment, right? So I think so much of the community, we've brought up, we're in this little proactive window. We have a little bit of time as a community to get ahead of this before it's as big as the cyber community has seen the cyber world really explode and blow up over the last 10 or 15 years. But I think we've also brought up the necessity to have the partnerships and the collaborations around this space, taking advantage of that proactive window as a community. We're very much taking advantage of that with a lot of the collaborations that we've stood up, both with Bob and the cross-government and community collaborations on that angle, and with our industry partners, because it's absolutely not going to be something that any of us solve in an individual silo, whether that's organizational silo or cross-government industry or international, even with like our NATO partners here, right? We're seeing that we need to share our ground truth on the data of what's actually happening, what can realistically impact our systems, and then those tools, capabilities, and techniques that we can share across the community to do something about it. Maybe it's our closing thought, at least from my perspective here, is that most of the different collaborations we've brought up today is something that all of you can participate and become part of. So much of this industry collaboration happening around all of this is not just experts in this space, but people coming up to speed on what their risk looks like here, right? This is at least just keeping an ear to the ground on what threats are coming down the pike to impact your systems. So everything from experts in the AI security space all the way down to folks that are just starting to implement AI or machine learning models inside of their larger system of systems context. It's important that we as a community maintain awareness and share what we know about these risks that we're facing and what we can continue to do about it.
So we have two more questions for the panel that I'll raise, and then we'll close. But before I do that, I always hate being caught off guard as a panelist, so fair warning. I'm going to ask you, what is one piece of reading material that you would recommend to the audience on this topic? So just think about that while we're covering these last two questions. So Neil, just to you, what are some contrarian takes on AI or AI security?
Yeah, really good question. One is that I think the future of AI will obviously play, this part's not contrarian, will obviously play a really big part in what we need to do from a security mitigation perspective. I think that over time, we're going to see organizations build fewer and fewer models internally and rely more and more on foundation models. Foundation models are the large language models. They're these really, really large models in multiple domains, from computer vision to text to tabular, that cost millions, tens of millions, and soon hundreds of millions of dollars to train. And we're going to use these kind of models as our underlying layer for a lot of our tasks, especially on the enterprise side of the house, and on top of it, customize these models for our use cases and our applications. And so we almost have this third-party risk kind of as the underlying layer in everything that we do from a machine learning perspective.
Bob and anyone else on the panel, what is the most game-changing technology with AI and ML as we look forward?
So I think looking at multi-model or ensemble systems that are leveraging multiple models, either operating sort of in a cascade effect or in parallel with each other, I think that's an interesting capability that's on the horizon. I think it also introduces a next level of threat vector, because now not only are you worried about the individual model and its performance, but now you have to worry about the system, the feedback system between multiple models that are deployed in an ensemble system.
Neil, Christina, any thoughts?
The one other thing I would build on, because Bob, you hit the nail on the head there. I think the other element of this, especially from the AI security and assurance standpoint, is that so many of these systems that we're deploying, like it's organizations when they'll say like, okay, I'm not actually employing that complex of a system here. I don't need to be that worried about adversarial machine learning. If you're deploying AI in any environment where any actor might want to misuse or evade or attack that system, your system is vulnerable, right? So it's not just super advanced tech giants or anybody that's deploying AI in a massive way, right? If your system is in any kind of consequential environment and someone might want to misuse it, then you incorporating AI and machine learning into that broader systems context is exposing it in such a way that it can be attacked in new ways that you're probably not thinking about or necessarily prepared for. So absolutely, I think the set of solutions that we're going to see, both adapting and evolving in this space, are going to be multimodal. I think we're going to see the tools and capabilities coming out of it are going to be very, very exciting. But also, if we're doing that in an important or consequential environment, we're making ourselves vulnerable there in ways that I think all of our systems are going to be attacked or vulnerable to attacked. And we should at least be thinking about red teaming them, poking at them ourselves before adversaries are doing that for us.
Just to add on to that point, what we're also seeing is the advent of the proverbial script kiddie within the space, where it's become sufficiently easier to be able to launch an adversarial machine learning. And as a result, we're seeing more and more and more of these attacks. And so kind of reinforcing the importance of what Christina talked about from a AI red teaming perspective and from the perspective of taking your own internal precautions from the get-go.
Great. So last question for each of you. One recommended book or article for the audience on the topic. I'll start. Mine is Human Compatible by Dr. Stuart Russell at Cal Berkeley. Great book that takes you through the evolution of AI and the unknown frontiers that exist in the next 10 to 20 years. Bob.
So I'll give a plug for the national security side of the house. Recommend reading the final report for the National Security Commission on Artificial Intelligence. It was an independent congressional panel that was chaired by former Deputy Secretary of Defense and Eric Schmidt. And there was a lot of work put into that report, a lot of current thinking in AI security for national security comes out of that report. It's about that thick, so maybe some good nighttime reading, but highly recommend a lot of the conclusions in that report.
Neil?
There was a paper that was released in 2016 by the Oxford Center for Existential AI and a number of other organizations talking about the future of AI risk. It goes kind of far beyond the bounds of where we are now from the perspective of where we are from an AI perspective, but it's a really fascinating read with a lot of the kind of early thinkers. Unfortunately, it's also about this thick, so once you're done reading all of these materials, you'll probably be ready for the next RSA.
I'll maybe help ease our reading list a tiny bit here and say that there is an exec sum for the NSC AI report, which is one of the ones that I was going to bring up. And then as well, NIST and others have also put out some really good literature and papers, even just in the last few months on this topic. But even one step higher, we've actually done some adversarial machine learning and AI security 101 pages, even built into the Atlas Matrix or on the GitHub pages, right? So if you're just starting to come up to speed on this topic, maybe dip your toes in with the exec sum and start exploring some of the open source resources that our Atlas community or others have already put out there, so you can start to better understand exactly what we're talking about in this space.
That brings us to a close. I'd like to thank Bob, Neil, and Christina for their time today. For me, it's always great to be back at RSA with audiences like this, and I'm sure I speak for the panel. So thank you for your time today, and we'll look forward to catching up with you next year.
Thank you, Brian, for moderating.